Hello. Yeah. Okay, so this was what we saw earlier. We were talking about how we generated this output yfn. So in general, if I am able to write my input, x of n as xk del of n minus k goes from minus infinity to plus infinity. So this is my any arbitrary x of n, I can write like this. And the input to the system, if I give del of n minus k, if I give this, I get hk of n. Then the output, when I give this x of n as input, if the system is linear, will be y of n, which is equal to x of k hk of n, where k goes from minus infinity to plus infinity. So essentially we are able to determine the output to an arbitrary input if we know the responses to individual shifted impulse functions. So this is coming because of the property of linearity of the system. Now in addition to linear, if the system is also time invariant, okay, then basically what that means, let us call the response to the delta function at 0. Essentially, if you have a del of n, the response is now going to be at 0 of n. Okay, let us call this as h of n. Okay, at 0 of n, I'm calling it h of n. So now, if the system is time invariant, my hk of n, which is nothing but is, if the system is time invariant, then this will be hk of n will be h of n minus k. That is, if the input is del of n minus k, I get hk of n. So if the system is time invariant, by hk of n will be nothing but h of n minus k, where h of n is the response to del of 0. Essentially this means that if the system is linear as well as time invariant, an arbitrary input x of n will generate an output y of n, which is given by x of k h of n minus k goes from minus infinity to infinity. Okay, so basically what this means is the characteristic of the response to the delta function del of n is enough for you to produce the output to any input, provided that the system is linear and time invariant. So this is a very important relationship. It is so important that it has its own name, and we write this as y of n equal to x of n star h of n, where star represents the convolution operator. So this operator is called the convolution operator, and the output of a linear time invariant system is computed using the convolution operator, and the convolution is performed on the response to the h of n, which is called the response to the unit impulse. Essentially this is what is known as the unit impulse response. Hence the unit impulse response h of n for an LTI system is able to completely characterize the output of the system for any input. Okay, that is the end of this lesson.